Okay, Calc, this is the whiteboard problems that I have for Chapter 5 review. We're going to start, and I'm just going down the list of problems that I know will probably be on the test. First, going to start with one like this. We didn't do one like this on the review, I don't think, but we did this once upon a time when we started talking about, like in section 1, okay, talking about absolute maxes, absolute mins, all that good stuff. So, first problem. Pause after I explain the problem, and then you can fill it in, and then I will reveal the answer to you. So going through each one of these points here, A, B, C, D, E, F, which ones are absolute maximum, absolute minimum, relative max, relative min, and neither, okay? So pause, label them, and then I'll give you the answer. All right, here we go. So A is going to be the absolute highest point on your graph because all these other ones are lower than that. So I'm going to label A as the absolute max, okay? B is going to be the absolute minimum point, okay? C is like kind of a POI actually, but we don't have POI as an option, so he is a neither point. D is going to be a maximum point. He's a high point, but he's not the highest point, so he is a relative max. E looks like a minimum, but he's not because he is an open circle, so E is going to be a neither point, and then F is another high point, but it's not the absolute highest point, so F is the relative max. We have no relative mins here at all, and that is the result of this table. Okay, so go back through those again if you got any of them wrong, and try to figure out or ask somebody why it is the way that it is. I'm going to move on to number 2. This one is asking just to find the critical values, okay, or like the critical numbers. So starting with this equation, we're just trying to find what the critical numbers are from the first derivative, second derivative, okay? So we know that we have first derivative critical numbers, we have second derivative critical numbers, and then we have to look at VAs also, if there are any, okay? Will this thing have any VAs? No. This one does not, okay? So go through and find your first derivative, set that equal to 0, find your second derivative. You do not have to do the whole process, okay? Pause, do that. I'm going to give you the answer now. So, first derivative, 3x squared plus 12x plus 9. I really hope I can do this without screwing anything up. Okay, setting them equal to 0. So, I'm going to divide everything by 3 because it divides by 3 really nicely. And then I have x squared plus 4x plus 3. Ugh, why is it doing that? I don't know why it does that. Anyway, plus 4x plus 3. Okay, this is a simple trinomial. X plus 3 and x plus 1. So that means my critical numbers are -3 and -1. Okay. Second derivative, I'm going to take this guy, what I originally had before I divided by 3, and I'm going to go 6x plus 12 equals 0. And if I subtract the 12 and divide by 6, I have x equals -2, I think. So I have 3 critical numbers technically, 2 of them from the first derivative, 1 of them from the second derivative, and then if I would go to do the whole process again, I would find increasing, decreasing, concave up, concave down. We're going to do that later on down here for a couple problems, but just for now, the critical numbers, just finding those. These two right here, the -3, -1, those are possible maximums and minimums. This guy is just going to be possible POIs, okay, because that's where first derivative is max min, second derivative is POIs, okay? So there is all of that good stuff. All right, now we're going to go and actually do this whole process on this equation, which is going to get a little cumbersome. So looking for domain and range, looking for va and ha, looking for the rest of this stuff, okay? Increasing, decreasing, max, min. If you need to make a note of that, this is all from the first derivative. Concave up, concave down, POI is all from the second derivative, okay? So if you want to go through this one together and then try this one on your own or vice versa, I don't care, whatever. I'm going to do these 2 problems, okay? So pause if you need to, fill those in, see what you get, okay? Domain and range. This one's not going to have any negatives inside of a square root or division by 0 that we have to worry about, okay? So his domain is going to be all reals. Therefore, his range is going to be, well, I don't know if I really want to do the range because you can't really tell the range unless you plug numbers in and look at the graph. I shouldn't have put range on there. I don't think I put range on the test. We're going to skip range. I guess this one. This one is an x to the third power, so I know it goes up and down forever. So the range will be all reals for that one. Okay? But x to the fourth power could be a w, so I don't know how, like, low he goes. I don't know. For range, we're going to skip range, because you would have to, like, graph it, or have the graph of it. And, like, yeah, we're going to skip range. Va. There's no va. There's no ha, so none of that. Then we do our derivatives. Okay, so let's do first derivative. And let's do second derivative down here. First derivative is 4x cubed minus 16x, I think. And if we set equal to 0, I'm going to take a 4 and an x out. And I'm left with x squared minus 4. And this guy, whoa, this guy is a difference of squares. This is x plus 2x minus 2. Okay, so I got 4x and x plus 2x minus 2. So if I set this guy equal to 0, this guy is 0. If I set this guy equal to 0, that's negative 2, and this one's positive 2. Holy crap. There's 3 critical numbers. Those are 3 possible maxes and mins. Yikes. All right, second derivative is 12x squared minus 16. And if I set that equal to 0, this is so not great. I picked some bad numbers. Okay, sorry, guys. Holy bejeez. Holy bejeez. I don't know if I really want to do this problem. This is really ugly. All right, so let's add the 16 over and divide by 12. So x squared equals 16 over 12 is, I don't know, divided by 4 thirds. I don't know, 4 thirds. And then we have plus and minus the square root of that. Ugh. Plus minus square root. That is so disgusting. Yuck. Okay, so, oh my heaven's sakes. I think I'm going to abort mission on this problem, and we'll go to a nicer one. Yeah. This is. I'm not going to give you something this ugly on the test. I really thought this was going to be nicer. We have 1, 2, 3, 4, 5 technically plus minus. That's 5 things, which means we're going to have 6 test intervals. Holy crap. Yeah, we're gonna not do this. Yeah. I'm going to write out my test intervals, and we're going to abort mission. Negative infinity 2, the square root of 4 thirds. Hold on. Let's see where that guy lives. 4 thirds. And then the square root of that square root is 1.15. So this is positive 1.15, and this is negative 1.15. Okay, so coming first would be like negative 2. Then I would go negative 2 to negative 1.15. Then when I would go negative 1.15 to 0. I don't know. 0 to positive 1.15. And then 1.15 to 2. And 2 to infinity. Holy crap, that's a lot of stuff going on there. Okay. So, what you would do is you'd find a test point in each one of these intervals, right? And depending on whether it was plus or minus for the first derivative, that would tell you increasing, decreasing. Increasing, decreasing. And then f double prime would tell you concave up or concave down. So, whatever those numbers that you're finding from this interval plugging into the first and second derivative, that will tell you increasing, decreasing, concave up, concave down. Okay, I'm not going to fill that table in because that is just atrocious. So sorry if you actually did it yourself. Let's go over to this one, who hopefully will be a little bit nicer to us. I know that this guy's range will be all reals, and his domain will be all reals, okay? He has no negative inside of square root division by 0. Now, the reason why I know his range is all reals is because x to the third power is going to do something like this. So, regardless of what his humps look like in the middle, he's going to go up forever and down forever. Whereas x to the fourth power does not do that, so I did not know that this guy's range over here was all reals, okay? The vase, he doesn't have any. Ha's, he doesn't have any. Okay, now let's do our first derivative. 3x squared minus 12 equals 0. That one's a little bit better. Oh, heavens. Okay, 3x squared equals positive 12 if I move the 12 over. And if I divide by 3, x squared is 4. And x is plus minus 2. So that's 2 critical numbers right there. Okay, then if I set, that's my first derivative. My second derivative will be 6x, and that's it, right? 6x, the 12 will go away. If I set that equal to 0, x will be equal to 0. So this is my possible maxes and mins, and this is my POI probably, okay? All right, so this one's going to be a little bit better because, I mean, it's a little bit better. Okay, we have 3 numbers, which means we're going to have 4 test intervals. So it's going to be kind of still a little bit icky, but, you know, whatever. Negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. Okay, so we should be able to pick at least some whole numbers. Like I'm going to choose negative 3, I'm going to choose negative 1, I'm going to choose positive 1, I'm going to choose 3. Okay, and we're going to plug into the first, we're going to plug into the first derivative, we're plugging into the second derivative. Okay, here we go. First derivative was, I got to think, 3x squared minus 12. All right, I'm going to write that down here, 3x squared minus 12. Okay, if I plug in negative 3, this guy will be positive 9 times 3 is 27 minus 12, which is positive. If I plug in negative 1, squared is 1 times 3 is 3 minus 12 is negative. Positive 1 will be negative again, and positive 3 will be positive again. Yeah. The second derivative, which was 6x, if I plug in negative 3, that's negative. Negative 1 is negative. Positive 1 is positive. Positive 3 is positive. Okay, so, all right. This guy tells me, this guy right here, this plus tells me he's increasing and decreasing and then decreasing and increasing. Okay, here he's concave down. Here he's concave up. Okay, so I'm going to write down those intervals. Increasing was from, right here, was from negative infinity to negative 2. Also increasing from 2 to infinity. Okay, decreasing, I could just lump this whole thing together and go from negative 2 to 2 for decreasing. And what that means is that here he's increasing, here he's decreasing again, and here he's increasing. So this guy is going to be a maximum at negative 2 comma something. Here he's nothing because he's decreasing. Here he's decreasing, increasing. So here he is a minimum at positive 2 comma something. Okay. All right. He is concave down from negative infinity to 0. I can lump these two together. So from negative infinity to 0, he's concave up from 0 to infinity. And that means I have a POI at 0 comma something, right? Where he switches right here. So now to figure out these coordinates, this one, this one, this one, okay? To figure out those coordinates, I'm going to plug into the original guy, which is this one, x cubed minus 12x. Okay, negative 2 cubed minus 12 times negative 2. This is negative 8 plus 24, which is like 16, I think. Okay, then positive 2 cubed minus 12 times 2. This is positive 8 minus 24, which is negative 16. And if I plug 0 in, 0 cubed minus 12 times 0 is 0. So there's all my stuff. That was a lot nicer. That was a lot nicer. Okay, that will probably be more comparable to what was on the test. So if you can handle that one, you're good to go. This one, you won't have anything that's that ugly. Okay, hopefully. No, you won't. I promise you won't. Okay. All right. So go back through that if you need to. I'm going to move on to the next thing. We have I gave you a couple Rolle's theorem to look at, and then I have a mean value theorem. Okay. So Rolle's theorem, first and foremost, you want to make sure that you can do Rolle's theorem on these two things. So like there's no vase, there's no holes, there's no piecewise functions, there's no tippity tips, right? And I don't think with either of these functions we're going to have any of those, okay? So this one says, find the x-intercepts, okay? Here for Rolle's theorem, it says verify that y coordinates are the same for these two, okay? So in one, they say find the x-intercepts because if I'm doing x-intercepts, they're going to be directly across from each other, okay? Same thing with this one, but they wouldn't have to necessarily be x-intercepts. Like they could be like up here somewhere, right? They wouldn't have to be x-intercepts in order for the y coordinates to be the same, okay? So I mean, doing the same thing, but doing it just a little bit differently. Finding the x-intercepts here. They want us to do that by setting the y-coordinate equal to 0. So I'm going to break this thing down. And I know this is a simple trinomial, so I'm going to multiply to get 15 and add to get 8. So x plus 5 and x plus 3. And x equals -5 and x equals -3. Yeah, x equals -3. Those are my two x and y, or x-intercepts, okay? Now it wants me to find, so I found my x-intercepts. Now it wants me to find where the derivative is equal to 0. So I'm going to take the derivative first. Derivative is 2x plus 8. Oh my gosh, why does it keep doing that? Somebody tell me why my pen keeps doing that to me. 2x plus 8 is my first derivative. If I set him equal to 0, x is equal to -4, which means that these two places right here are my x-intercepts. They are directly across from each other at -5 and -3. They're going to be directly across from each other. But at -4, which is exactly in between them, -4, he's going to have a hump, okay? And because this is a parabola, and I know he's a smiley face, he's probably going to be a hump that looks like this. So my derivative is going to be 0 at -4, same as the slope between -3 and -5, okay? So that's how Rolle's theorem works, right? We found the x-intercepts. They're directly across from each other, and -4 is the point where he has a hump, okay? All right, now here it says verify that between -2 and 6, I have the same y-coordinates. So I'm at -2 comma something, and I'm at 6 comma something. We just want to make sure that these two coordinates are the same value when we plug them in. So if I plug -2 into that, -2 squared is 4, minus 4 times -2 is a positive 8, minus 12. 4 plus 8 minus 12 is 0. Okay, hey, there you go. 6, if I square him, is 36 minus 24 minus 12. That's also 0. Wait a second. So these are the x-intercepts. Huh. Okay, that was just kind of a different way of asking for the x-intercepts. They wouldn't have to be x-intercepts, but whatever. Okay, now we know that these have the same, or the same spot directly across from each other. Now we want to find them where the derivative is 0. So I have 2x minus 4. This is going to be kind of the same thing. Maybe. No? Yeah, 2x minus 4. And I set that equal to 0. And I add the 4 over. Plus 4. So 2x equals 4. And x is 2. Oh yeah, there we go. 2 is going to be the place where the hump occurs. And that is an x-coordinate between -2 and 6, right? So -2 and 6 have the same across from each other, and positive 2 is going to be where the hump is. So probably like this, actually. Okay, he's going to have a 0 tangent line, or a horizontal derivative at that point, okay? All right, now mean value theorem, if you remember mean value theorem, they're not directly across from each other. They look like this-ish. And then you have a hump in between them when we're trying to find where that also has the same slope, okay? All right, so this is the wording that they'll ask, and it's kind of ugly. It says, find where the derivative, f prime, is equal to this. But that is like y2 minus y1 over x2 minus x1. That's just saying the slope, right? So my endpoints are 0 and 2. 0 comma something and 2 comma something. And we're going to plug those into here, and we're going to figure out what what our stuff is. So 0, if I plug that in, that coordinate is 0. If I plug 2 in, 2 cubed minus 2, that will be 6. Okay? Now I want to do the slope of that, right? I want to do the slope of this guy. So y2 is 6 minus 0. x2 is 2 minus 0. So this would be 6 over 2, which is 3. Now, rather than setting the derivative equal to 0, like we did for Rolle's theorem, we're going to say, where is the derivative equal to 3, right? So my derivative is 3x squared minus 1, and I want to know where that's equal to 3. Okay, so this is going to be kind of icky. I'm going to add the 1, plus 1, so 3x squared equals 4. And if I divide by 3, and take the square root, x equals plus and minus the square root of 4/3. Now here's the deal. Plus and minus the square root of 4/3, we just had that up above. It was like 1.15, right? So this is like plus and minus 1.15 as a decimal, right? I only care about the one that falls in the interval from 0 to 2. So I'm really only caring about the positive square root of 4/3, because that is where he lives in my interval. So if here is 0, 0, and here is 2, 6, 0, 0, and this is 2, 6, those are my endpoints. 4/3, which is 1.15, about there-ish. This is probably what it looks like, so that it has the same slope. Okay, this is the 1.15 comma something. Okay, so I know that the x-coordinate has to be the square root of 4/3 or 1.15, and that's going to have the same slope of the tangent line that has the same slope as that secant line is what it's called. Okay, so that's mean value theorem. Study that over if you have any questions, because you will have one like that, I know for sure. And then we get to limits. These should be like hopefully the free points. So you will have to remember your rules for n and m. If n is less than m, if n is equal to m, and if n is greater than m. Okay, I know n equals m means that the limit is the leading coefficients, right? Okay, but then these two are the ones that I get confused a lot. And I just remember if he's top heavy, like if the top is bigger than the bottom, he's going to fall over. So he's going to be none, right? If the top is smaller, then he's 0. Okay, so my limit's going to be 0. All right, so remember those rules when you're going through and doing these guys. Let's figure out what these are. If you want to try them on your own, go for it. Here we go. N, in this case, is 1, because he's to the first power. M is 2, which means this is a 0 limit. Okay, it's gonna level out to be 0. This one, your N is 5, and your M is 2. So that means he's top heavy, so he will not have a limit. He will not approach anything in particular. He'll just kind of be like scattered all the way through. This guy, your n and m are both 3s, so I'm looking at the leading coefficients, which do reduce. 2 over 6 is 1/3. That's what he will reduce to. And then this one has a square root. So the deal here is, when you're looking for n and m, like I know my m is going to be 2, but my n, the top, is the square root of x to the 4th power, which was actually going to be 2 also. So the fact that these two are the same number means that I look for the leading coefficients, right? This guy's leading coefficient is 1, and this one is 3. So it is 1/3, except this is the square root of 1, right? The square root of 1 is 1, right? So this stays 1/3, but the square root of 1 is plus and minus 1. So plus and minus 1/3 is going to be your limit, and that's how that works, okay? All right, a couple more. These are the story problems, and then I'm done. All right, this one is asking for finding 2 positive numbers. Okay, so before we read any further, let's talk about our 2 positive numbers. We don't know that they're the same number, so we're going to call them 2 different things. We're going to call them x and y, or whatever variables you want to assign to them. We know that the product of them is 147. So we usually have a primary equation and a secondary equation. Okay, you always put what you know in the secondary spot, and if you put it in the primary spot, I don't really care. Like, whatever. You just need one equation that you know and one equation that you're trying to either maximize or minimize. So I'm going to put secondary. I know product is equal to 147. The product of x and y. The product is just x times y, so that's what I know. I know x times y is 147, okay? Then it says the sum, which means we're adding, okay? The first number, which is x, and 3 times the second number, which is 3 times y. I want that to be equal to a minimum number. I'm trying to minimize that, okay? So what we're going to do is, let's do this. Let's solve for x. It doesn't matter which one you solve for. I don't care. Let's solve for x. And that's 147 over y. Let's do that. And we're going to take this guy and we're going to plug him in right there. So I have 147 over y is going to take his place. Now, before I take the derivative, I'm going to make that instead 147y to the negative first power plus 3y equals a minimum. Okay, and then I'm going to find the derivative. So I moved that y to the top and made him to the negative first power. That's a 1. That kind of looks weird. All right, so let's find the derivative. So the negative 1's going to come down in front. So negative 147, y to the negative 2 power, plus 3, because the y drops off. That's what I'm trying to minimize, and I'm going to set him equal to 0, because when you're trying to find maxes and mins, they're going to have a horizontal tangent line or a derivative that is 0. All right, now let's solve. I'm going to bump this. Well, no, first, I'm going to take this guy, and I'm going to say that's going to go on the bottom, right? Y squared goes on the bottom if it's y to the negative 2. Then I'm going to bump him to the other side. So I have 3 equals that 147 over y squared. Now it's positive 147 over y squared instead of negative. Okay, last thing, times y squared, so 3y squared equals 147, and then I can divide by 3. So y squared equals 147 divided by 3 is 49. And if I take the square root of that, y is either plus and minus 7, but we know that they have to be positive numbers. So y has to be a positive 7, okay? I guess now the last thing is that I have to find the x coordinate. And I'm going to go back to, I don't know why it's pulling that up either. I'm going to go back to this equation, and I'm going to plug 7 in here. So 147 divided by 7, that means our x coordinate is, I think, 21, okay? So my product, the product, or 21 times 7, is going to be 147, but I know that x and 3y, like the relationship is the same, right? Like x is 3 times what y is, and that's kind of how minimums work or whatever. So that's with numbers. Now we have another problem, and I hope I have a calculator that will do this for me. So determine the dimensions of a rectangular solid. This is the last question. Determine the dimensions of a rectangular solid with a square base and a maximum volume if the surface area is this. Okay, so the primary equation and the secondary equation. I know that the surface area, which we'll have to write out the equation for, is equal to 337.5. And then the volume is what I'm trying to maximize. I'm trying to find max volume. Okay, let's draw what this thing looks like. A rectangular solid with a square base. Okay, I'm going to make the square base like the front, because that's the only thing I know how to do. This is like a shoebox kind of, or a Kleenex box. There you go. And this is a square right here. And the reason why that's a square, or that's important, is that we can call that x by x, right? And then we don't know that this dimension is the same, so we're going to call that y, right? So he might be longer in that direction, but he's x by x by x by x, and then we have y. All right. This rectangular solid has all of its surfaces, not like the top isn't open or anything like that. So when we go to find surface area, we have 6 surfaces. This front surface is going to be x by x, so that front surface is an x squared. And the front surface and the back surface are both going to be x squared, so there's 2 of them, okay? Then this side surface right here is an x by y, so it is an x times y. And then this is also going to be an x times y. This side is going to be an x times y, and the bottom side is going to be an x times y. So I have 4 of those, and those are my surfaces added together. So I have 2x squared plus 4xy, and that is equal to 337.5. That is what I know, okay? When I go to find the volume of this figure is just length times width times height, or whatever. So x times y, or x squared y, come on, x squared y is going to be my volume equation, all right? Okay, so just think that through, go through all the surfaces. There's 6 surfaces, and then volume is length times width times height, okay? All right, now we've got to plug one equation into the other one, all right? These are the tricky ones. So I've got to decide if I want to solve for x or solve for y in this bottom equation. And the easier one to do is the y value, because I only have 1 of those. So let's bump this. Let's subtract 2x squared to the other side. So I'm just going to do that. Okay, 4xy equals 337.5 minus 2x squared. All right, then if I divide by 4x and divide by 4x and divide by 4x, okay, y is equal to 337.5 divided by 4. I'm going to do that. 337.5 divided by 4. And that is 84.375 over x, because the x is in the bottom. So I've reduced this part, and then I still have x in the bottom. Minus this 2 over 4 is 1/2. And x squared over x, I still have an x in the top. So that's what he will look like. Okay, so kind of a mess, but whatever, it'll be fine. Okay. All right, now this guy is going to go in for the y coordinate up here. So I have x squared times that, all that junk, 84.375 over x minus 1/2 x. Okay, now this x is in the bottom and this x is in the top, technically. So when I distribute my x squared through, okay, like this guy will have an x squared on him, and we'll have, this will be x to the third power. But this x squared can cancel with one of those. So I just have 84.375 x on the top, no x on the bottom, minus 1/2 x cubed. That's how that will work. Okay, finally, we are to a point, and we haven't even taken the derivative yet. Great. Okay, let's take the derivative. 84.375 minus 1/2 times 3 is 3/2 or 1.5 x squared. Okay, now we set them equal to 0. We're getting close. Equal to 0. And I'm going to bump this over to the other side. So 84.375 equals 1.5x squared. I'm going to divide by 1.5. Okay. All right, that number divided by 1.5. 56.25. And then I'm going to take the square root. And I think it comes out a decent number. Yeah. X equals 7.5. There we go. Okay, so my x dimension is 7.5 units, or whatever that is. Okay, if you need to go back and write that down or look through that at a slower pace, go for it. But the x dimension is 7.5, so it is 7.5 by 7.5 by, we have to figure out what the y coordinate is. So, oh my heavens. Y is equal to this right here. So 84.375 divided by 7.5 minus 1/2 times 7.5. Okay, yuck. All right, 84.375 divided by 7.5. All right, you guys are not allowed to do any complaining about how cumbersome and ugly this is, because I am sitting here with a phone calculator trying to do this. This is 11.25 minus half of 7.5 is 3.75, I believe. Okay, so minus 3.75, and that is, oh my goodness, 7.5 also. What? So the max volume is going to occur when it is a perfect cube. I could have probably guessed that. That stinks. Anyway, so there's that. Determine the dimensions. 7.5, 7.5, 7.5. There we go. It is a perfect cube. Look at all of that. That's a lot. Okay. The difficulty level of the one that you will have on the test will probably be somewhere in between this one and this one. Okay. I don't think it will be quite as difficult as this one. So if you can get through that and at least could make sense of it, you're going to be A-okay. All right. It might be a little bit harder than this one, though. So be prepared for that. Okay. Otherwise, I think that should do it. Look at all those ugly things. Sorry for that. Yeah, this problem, you can just nix that one. That one was ugly. Sorry. I thought it was going to be nicer than it was. Okay? All right. So hopefully that gets you through. And let me know if you have any questions.